Crazy walks 55 meters east. He then turns a corner and goes 40 meters south. After that, he goes 15 meters west and then 10 meters north. Lazy, starting at the same origin as Crazy, walks to where Crazy ends up. How far did Lazy walk and in what direction? So what we're going to do first, we're going to separate our x and y variables. So blue will be our x direction values, and we'll say purple is our y direction values. Alright, so first, Crazy walks 55 meters east. So to keep things straight, let's go ahead and draw our graph complete with the unit circle. This would be east, which is 0 degrees, and then north, which is at 90 degrees, west, which is at 180 degrees, south, which is at 270 degrees, and then east is also 360 degrees. Alright, so he walks 55 meters east. So we know that's 55 meters to the right. So that's going to be a positive 55. And then he turns the corner and goes 40 meters south. Alright, south is our y variable, and since it goes down, it is negative, so that's going to be a negative 40 meters. And then he goes 15 meters west. Now west is negative. He goes 15 meters at a 180 degree angle, technically, so this is negative 15. And then he goes 10 meters north. North is a y value because he went straight up, and since he went up, it's going to be positive. So we're going to add these together. Negative 40 plus 10 is negative 30, and 55 minus 15 is 40. So what he ended up doing was going 40 meters in the positive direction, and then 30 meters down in the negative direction. Let's try that again. Okay. So what we want to know, this is Crazy's path. Lazy, being lazy, starts at the same place, but he just walks right to where Crazy ends up. So what we want to know is, how far did he walk here? We know that this is 40 meters, and we know that the magnitude of the length for this side is 30. So what we're going to do is use the Pythagorean theorem. We have a squared plus b squared equals c squared. We plug those in. 40 squared plus 30 squared equals something squared, but we don't know what that is. So we're going to grab our calculator. We're going to make sure, before we even get going, that we are in degree mode. Very important. Alright. Now we do 40 squared plus 30 squared, and we get 2,500. So over here we can say that 2,500 equals c squared. But we don't want c squared, we just want c. So what we end up having to do is taking the square root of both sides. Let's see, we'll do that one. So we have to take the square root of c squared and the square root of 2,500. And what we end up getting square root of 2,500, and we get 50. How about that? So C equals 50 meters. Wow, crazy went the total of all of these, 55 plus 40 plus 15 plus 10, Lazy only went 50. But we want to know, what is the new direction of Lazy's path? So what we're looking for here is this theta, and once we find it, we can subtract it from 360 to find the direction. There's the direction in which Lazy traveled. So the way that we find our theta is we use some trigonometry. So we have choices. We could either use sine theta equals opposite over hypotenuse, or cosine theta equals adjacent over hypotenuse, or tangent theta, which is opposite over adjacent. And we know that since we're trying to find theta, we're going to use the inverse. Well, here we actually have the angle that's opposite. Our y is opposite of the angle, and 40 is actually our adjacent. So x is our adjacent side. So we have opposite and adjacent. Tangent happens to be the trigonomic function with opposite and adjacent, so we're going to use the inverse of tangent, y over x, or opposite over adjacent, to get our theta. And once we do that, we already checked we're in degree mode, so the inverse tangent of y over x, our y has a magnitude of 30, and our x has a magnitude of 40, opposite over adjacent. When we press enter, we get 36.9. So our theta equals 36.9 degrees. But we're not done yet. We have to subtract 36.9 from 360. So to get our theta, we take 360, subtract 36.9, and we get 323.1 degrees. So this is our direction. So Lazy's resulting motion is 50 meters at 323.1 degrees.